Good morning, everyone. Firstly, I will thank for giving this opportunity to demonstrate my project. I would like to introduce myself, Rokkam Gayatri. I am from Rajmundry at East Godavari district. I am pursuing BTech 4th year in EC department at Rajiv Gandhi University of Knowledge and Technologies, IIIT Ongole, and I am doing intern at MX Solutions in Embedded Systems. Here I am going to explain about internship in embedded system internship, and also I could like to explain the implementation of micro oven stimulation. Before going to the explain the presentation, let me explain you the topics which are covered in throughput the internship, which are introduction to C, what is embedded systems and microcontrollers, conditional loops and operations, arrays and pointers, functions and strings, storage classes, MpLAB IDE, XCB, PixSimLab, introduction to various peripherals, PIC16F877A, interfacing various peripherals of PIC16F877A, following by multiple quizzes. Coming to the presentation, the main agenda contains introduction to micro oven, what is embedded systems and its types, microcontrollers and microprocessors, requirements, project implementation, working and stimulation, results and conclusion. Coming to next slides, goals of internships. Basics of programming C language, brief explanation about embedded systems and microcontrollers, an overview of embedded programming and CCLD characteristic liquid crystal display. Under the banner of microwave oven project, we have learned practical and embedded programming language. Coming to introduction to microwave oven. A microwave oven is relatively small box-like oven that raises the temperature of food by subjecting into the high-frequency electromagnetic field. The microwaves are absorbed by water, fats, sugars, and certain other molecules whose consequent vibrations produce heat. We are going to implement four modes. They're as follows: micro mode, grill mode, convection mode, start mode. Coming to micro mode, this mode is used to clock food in a traditional way. It uses maximum power of 900 watts. In this maximum time that you set for cooking 60 minutes. Grill mode. This mode is used to cook meat. It works as the micro mode. User can set time as per the cooking time of food. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating it done, then the user can set the time as per requirements. Start mode. The start mode is used to start the function by the users. These are the modes. Coming to C programming, the C language is developed by Dennis Ritchie for creating system applications that directly interact with the hardware devices such as drives, kernels, etc. In this embedded system internship, we discussed about conditional and loops, operations, arrays and pointers, functions and strings, storage classes, preprocessors. Embedded system and its types. Embedded system is a combination of any hardware and software which is intended to a specific task. An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system as a part of a large system. At the core, it is an integrated circuit designed to carry out the computation for real-time operations. When classifying embedded systems based on performance and functional requirements, embedded systems are divided into four categories. They are real-time embedded systems, standalone embedded systems, network or networked embedded systems, mobile embedded systems. Types of embedded systems. Coming to types of embedded systems, there are four types: network embedded systems, mobile embedded systems, real-time embedded systems, standalone embedded systems. Network embedded systems are usually general purpose processors. Mobile embedded systems are embedded in mobile phones, camera, etc. Real-time embedded systems are designed to perform a specific task within a time frame. Standalone embedded systems work by receiving the input without using any ghost system after desired output. To a microprocessor is a compute processor where the data processing logic and control it included on a single integrated circuit or small number of ICs. The microprocessor contains the arithmetic logic and control circuitry required to perform the functions of a computer central processing unit CPU. The processor reads the settings input on the keypad into its memory. Signals are sent to the display, indicate the cooking mode and cooking period set. Microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. Microwave oven controller takes input from a keypad, displays output on a LCD display, and controls a relay that turns the microwave generator on and off. Coming to the differences between microprocessor and microcontrollers, according to the applications, microprocessors gaming, web browsing, document creation, etc. Microcontroller dedicated for specific task, camera, washing machine, etc. According to internal structure, microprocessors, memory and input-output devices connected externally. Microcontroller CPU, memory and input-output are present internally. Cost, microprocessors very high, it is low, and power consumption is microprocessor very high, microcontroller is very low. Memory, microprocessor is 512 MB to 32 GB. Microcontroller 2 KB to up to 256 KB. According to the storage, microprocessor hard disk 128 GB to 2 TB. Microcontroller flash memory 32 KB to 2 MB. Microprocessors according to the peripheral interfaces USB UART high speed Ethernet. Microcontroller UART 12C SPI. Coming to P16877A configuration, here may found there are 5 different ports, that is port A, port B, port C, port D and port E, and also we can see the timers, memory USRT and various elements like program counter, flash memory, flash registers, instruction registers. There are various tools which can be used to implement the microwave stimulation project. Going to the requirements of a micro oven stimulation project, mainly we require these types of tools, that is MpLAB IDE software and also PixSimLab. In PixSimLab that contains CLCD, that is character liquid crystal display. Coming to MKP matrix keypad. PIC microcontroller is a microcontroller where PIC stands for peripheral interface, controls 16F control bit processor on a chip memory, whereas 8 PIC 16F 877 is a model number and A is a revised version, and also the timers. Coming to the PixSimLab. PixSimLab is a real-time emulator of development boards with integrated MpLABX AVR GBD debugger. PixSimLab supports some PixSim microcontrollers and some SimAware microcontrollers. PixSimLab have integration with MpLABX Arduino IDE for programming the board microcontrollers. MpLAB IDE. MpLAB X Integrated Development Environment is an expandable, highly configurable software program that incorporates powerful tools to help you discover, configure, and develop, debug, and qualify embedded designs. For most our microcontrollers and digital signal controllers, MpLAB X supports automatic code generation with the MpLAB code configurator and the MpLAB Harmony configurator plugins. Coming to CCLD, character liquid crystal CCLD. In PixSimLab, there are two types of display, 16:2 display, 16:4 display. 16:2 LCD means it can display 16 characters per line, and there are two such lines. In this LCD, each character is displayed in 5:7 pixel matrix, and the 16:2 digital dot matrix display is capable of displaying 224 different characters and symbols. 16:4 display means it can display 16 characters per line, and there are 4 such lines. This is a popular 16:4 LCD with green backlight. It displays the ASCII character and some special characters. Two types of communication modes. One, 4-bit mode. Two, 8-bit mode. Coming to MKB matrix keypad. Matrix keypad consists of push button switches that are located to column and row intersections of a grid or matrix connected together as the switches in the same column. As we can see in the following figure, when you press a switch, it connects a row to column. These keypads are mostly used in digital lockers, telephones, calculators, etc. Coming to next slide, timers. Timers are used to measure specific time intervals, but in electrical engineering terms are also referred to a counters often. The timer is a component which is extensively used in different embedded systems. They are used to keep a record for different events occurring in the embedded systems. The timer is a simply binary counter which is configured into a circuit or a system as per the need to count the pulses in the system. The value of the timer is automatically set to 0 once it is an maximum value. Timer or counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, 8 or 16 bit, etc. Quantum, which depends on the system setting, is a measure of time which is responsible for sorry which is responsible for tick scaling, may be pre-scaler or post-scaler, maybe 1 is to 1, 1 is to 8, like that, etc. Coming to working principle and stimulation of projects, first let us know how the general wave micro oven works. Let us go to microwave stimulation. In order to implement the microwave overstimulation in the fixing lab and MATLAB IDE, we need to follow up the following steps to follow while initializing the project, and then go to projects. Let's click on create new. Next, microchip embedded. Next, standalone projects. Next, selects family, which includes mid-range 8-bit MCU. Next, select PIC16F877A. Then click on finish. Select the compiler tools. Chains. This is C8 compiler. Then next, give a name for the project as micro oven or anything. We want to select project location and the folder to finish. Create main.c files in the source files. Create main.h files in header files. Further move to Pixim Lab Stimulator. Sorry, there you may come across the following instructions like power on screen. It used to power on the microcontroller. Then menu display screen. To display modes, we can select PIC16F877A time display screen. It used to display selected time in the another. There are three options like start, pause, stop. Stop is used to interrupt the node. Coming to next slide. Before going to next slide, I want to say that the following modes of operation we may get. There are three modes: micro mode, grill mode, and the convection mode. Coming to output, first one is micro mode. For heating the food items, this mode is used. We select one by using push button in the display and set the time for minutes and seconds using keyboard. Next is grill mode for frying of food items. We select 2 in display using keyboard and set the time. If it's set to 20 seconds, after completion of 20 seconds, it again comes into display. Coming to convection mode, this mode is used to preheat for a particular temperature and it takes 3 minutes to preheat the oven. It is cooked heavy food at high temperature. It displays different to other mode. We have to set the temperature in this mode in degrees Celsius. And temperature should not be beyond 250 degrees Celsius. If it's set beyond 250 degrees Celsius, when we set beyond 250 degrees Celsius, it shows invalid temperature. Coming to advantages, simply it heats quickly. The convection is the best parameter while using the microwave ovens. It cooks food faster than conventional ovens. Coming to results, we may see the result as follows: power on screen, cooking mode display, micro mode, grill mode, convection mode, invalid temperature. Power on screen and cooking mode is here. We select of mode of operations. Convection mode, in this mode, if the input is beyond threshold temperature, that's the limit to it, it displays invalid temperature like this. We can implement the microwave oven stimulation like these modes. Let's move towards our demonstration of microwave oven. Here we can see I have used the two microwave software. First one is MpLABX IDE. This software is used for programming purpose. Here I have written the whole code into the main.c and included this all files over there. So let's first of all we have to create hex file into the MpLABX IDE. For that we have to build our project. So I just build my project as so I sorry as we see here build is successful. That means I don't have any error or any warning and loading is also completed. So the hex file we have created just now, we just have to upload the hex file into the SimLab stimulation for the stimulation purpose. So here I will just load the hex file. Okay, then first of all it will start the powering on the microwave. As we see here in the code, at the first stage at the first step it will powering on the microwave oven. This one here it will powering off the microwave one off for the some time, then it will jump into the cooking modes like this. As we all know, micro oven has four basic cooking modes, that is micro mode, grill mode, convection mode and start mode. We will see all those modes one by one in detail. First one, micro mode. As we hear by pressing key 1, that means k is equal to 1. We will into the micro mode. So I just press key 1, have pressed key 1 and this it's showing the power of the micro oven. So as we set, if there is a power is equal to 900 watts, it will be displayed the next one is the timer mode. It will jump here, our program will jump here and we will see that the set times, that means the minutes and seconds timers the next. So we'll just set the timer like here. I have set the timer like 55 seconds. That means 2 minutes 55 seconds. So for demonstration, this is very long time. So I just clear, if press star, it will clear out the as per the, and it will first clear out the minutes like this. Here, if I press again, that it will clear out the seconds also and starts the seconds blinking. So it will just give the 9 seconds for demonstration. Then I will enter the pressing the hash. It will enter into the OK. It will enter into that. So we hear 9 seconds 9 seconds timer. It will start 9, 8, 7 like this. If I pass like I have pressed the pass, it will pass the timer as well as it will stop the fan as we see here. I just will want to resume it or start it again. If I press 4, here it will start from that time. I press here OK. So here we see I just turn on the buzzer. Okay, so here we see buzzer will on the next mode is grill mode. Here we can see the grill mode. If we press the key 2, if you like press the 2, we will turn into the grill mode. I just press to here same as the previous mode as we said. The time here I have set suppose 9 seconds or 1 minute 9 seconds. I entered into it. If I press 4, so it will automatically increment the seconds by 30. If I press 4 like this, if we can see, if I press 2 times 4, then it will increment the minutes. Here I press 2 times, it will there like that. By doing this, after when this time will be completed, we will come out the okay. Okay, then next one is convection mode. As we all know, it is very important mode. Here we can see the key press equal to 3. That means from the convection keyboard in the cooking mode display, if you press the key 3, it will go. Here we have manually set the keys like temperature. So I just go into the convection mode. Okay, then here it is a convection mode. So if I press here, I have set the limits of the temperature like 250 degrees Celsius. If my temperature it goes beyond 250 degrees Celsius, that it will give me the error and it shows the message like invalid temperature and buzzer will be on. And after sometimes some delay it will turn off the buzzer. So I will just give the temperature more than 250 degrees Celsius. If I give 603.9, okay. So if you see here invalid temperature, okay. If I give below 250 degrees Celsius, it will goes into the preheating. As we hear preheating time, I have set it as 50 seconds. So let's move. If I give 120 degrees, okay, enter as we hear. Preheating automatically starts from the 15 as I set it here. So Up to this, we have to wait. We didn't do anything in the preheating mode until the time will turn off, as in the every mode. If we see if the door will be on, it will have to give us the warning that your door will want. Please turn off the oven. As we see here, I have mentioned that the buzzer will on and it will display that please turn off your door. So I press RB3. As we see the door status open, please close. If I release the key, then it will start again the preheating. So we see into the here MpLABX and MpLABX IDE. If we can see different types of sections, this is very reliable software. So we anyone can use or anyone can edit the code in the software as per the requirements. Here we have to use main.c file as well as the header files like main.edge, so that the conventions and object variables we have to declare all that into the main.h files. As we see here, I have declared all this power on screen. Clear mode display like that. So in the matrix keypad, I have to tell code about matrix. And then in timers, all these related to the timers did, sorry, all these related to timers, CCLD, do like this. The main used for the CLCD dock. This one is the CLCD dock display like this. We see into the Pixim lab, these are all about MpLABX IDE. Here, setting time, preheating time is finished, then it will automatically turn back into our main screen. Here, if I see last mode, if the start mode, okay, let's move into the start mode. If I press the 4 directly into the cooking mode, we will enter into the start mode. Here we have set the starting time is 30 seconds. If moves into start mode, it will automatically start the timer from 30 seconds. Let's see here, if we want to increase, if any user want to increase the time for, it will increase by 30 seconds. If double press, that will increase the minutes. If single press, it will minutes the increase seconds like that. So time is finished. FES turn off buzzer automatically turn on. This is all about our stimulation of micro. Conclude the project of microwave stimulation. Microwave processing technology requires to learn and understand. Micro oven will update according to technology, and mostly candidates for future prediction scales. Applications will take full advantage of the unique characteristics of microwaves. Microwaves are widely employed in modern technology, including point-to-point communication lines, wireless communications, etc. Overall, we observed working of different modes in microwave oven using PIC16F877A microcontroller in Pixim lab. Thank you for giving this opportunity.